Would you believe me if I say that hunger is the leading cause of death in the world? 8.9% of world's population and 22% of children under 5 are malnourished. Also, in many countries, severe food insecurity and hunger are major development obstacles. Although the earth has given us a wealth of resources, many people are starving due to the inefficient management of them. Therefore, the United Nations has defined two sustainable development goals, zero hunger and responsible consumption and production, that focus on these two major challenges. With this motivation, we wanted to come up with a solution by which everyone can contribute to agriculture. By this, we can make sure that nobody ever suffers from hunger or malnutrition. Also, by adopting environmentally friendly ways in our solution, we can try to undo the damage we have done on our planet and make it a better place for many years to come. Also, our country Sri Lanka is currently going through the worst economic crisis in its history. Many people are struggling with food shortage and rising prices. Therefore, we felt the dire need of cultivating in our own homes to fulfill the food requirement in every way we can. That's why we wanted to come up with a solution that can promote sustainable agriculture in a broader and a unique way. For this, we wanted to make our solution adaptable by everyone, even someone who is new to agriculture. So, it needed to be affordable, smart, and easy to use. It needs to solve challenges in cultivating, especially among urban communities. Also, we focused on making our design scalable and modular to make it easily expandable. Further, it needed to be highly optimized to achieve higher yield with minimal resources. With the vision on gardening for a better future, we came up with an ideal solution which we call the Green Machine. It is a smart IoT mini greenhouse that combines the power of edge and cloud computing. It harnesses the power of Intel FPGAs and also sensors by analog devices and Microsoft Azure Cloud. The green machines can look after the plants by providing automatic irrigation, ventilation, and light. We use a wide set of sensors to monitor the conditions within the unit. Multiple units can be centrally controlled, which makes it modular and scalable. We believe that the green machine will solve many of the challenges of gardening. Many urban communities struggle to find land for cultivation, but the green machine provides a way of gardening within homes. As it does all the hard work of gardening, it is not a burden to take care of plants, even in the busy lifestyle. Also, since the plants are grown indoors, many environmental hazards like excess heat and water by rain can be avoided. This paves the way for everyone to start contributing to agriculture. The users can grow some portion of their food requirement within their own homes. As the plants are grown within a controlled environment with optimal conditions, the users need minimal amount of chemical nutrients or pesticides. This ensures the safety of food and provide long-term health benefits. People can also improve the mental well-being by watching the plants grow. Green machines provide a solution to inadequate agricultural lands for urban communities. Since they can cater to urban food demand, conventional systems can be used for better distribution to achieve equal access to food. Our system is fully automated, therefore the farmers can save some of the costs they spend on labor, resources, and chemicals. The food can be offered at a lower price while the farmer is also satisfied. We can promote the production of customized and rare plants inside the controlled environment, which will improve the diversity in food production. Furthermore, this can increase the agricultural exports of a country as the demand from local consumers is less. Also, this simplifies the supply chain, which is a major carbon emitter. Our product efficiently manages water by providing exactly the required amount at the right time. Also, our design is very power efficient. It only needs 15 to 20 watt during full operation. Therefore, one could install a solar panel to a unit and make it self-sustaining. Also, harmful chemicals and greenhouse gases are not disposed into the environment. Furthermore, the data collected from our green machines can be used in research to find out new techniques for the betterment of agriculture. Now, we will look at the 5 main components of our design. First, we use cameras and a rich set of sensors to collect data from each green machine using a microcontroller. The next stage is transmitting the data over to the main controller. We have chosen Bluetooth technology for this as its power consumption is low within a short range. This data is received by our main controller, the DE10 Nano through RFS. Now the processing stage of our design. Here, the control system consists of mainly two parts, the convolutional neural network and the sequential control algorithm. First, the image data is fed into a convolutional neural network that classifies them into 6 categories. We could achieve a 95% accuracy in correctly classifying images. We implemented acceleration for this neural network on the FPGA fabric using OpenCL. Next part is the control algorithm. This is implemented on the HPS portion of the DE10 Nano. We made use of Quartus Prime design tools to interface the FPGA and the HPS. It processes the sensor data and image classification and determines the irrigation, ventilation, and light requirement and raise warnings if necessary. Then corresponding instructions are sent back to each green machine unit to activate the sprinkler system, fans, or LED lights. We chose to use the Terasic DE10 Nano with Cyclone 5 SoC FPGA as the main controller of our system. We identified the following characteristics of the FPGA to be useful in our design over a microcontroller. FPGAs have high computational capabilities that we can use to perform complex computation. This enables us to manage multiple units with a single FPGA with enough room to expand capabilities in the future. FPGAs are reconfigurable, so we can upgrade our system even after installation and give the user the ability to reconfigure it to their need without losing performance. It has the I/O capability to connect external peripherals to expand the features. Also, cost and power consumption of FPGAs are much lower than a microprocessor with the same performance. The Cyclone 5 combines the power of FPGA with the capabilities of a processor. We have utilized features of both of them in our design. The convolutional neural network is accelerated by the FPGA. This figure shows the FPGA utilization of the CNN model. It makes use of the best computational capabilities of the FPGA to handle complex matrix multiplications from multiple units. Also, a UART module is synthesized on the FPGA to provide reliable and efficient communication with the green machine units. The HPS portion manages a sequential part of the control system and memory. The HPS also has the capability to provide the Linux-based graphical user interface. With this, the users can easily control and monitor how the green machines are running. We use the network capabilities for communication purposes. This provided us the opportunity to develop a smart IoT solution. We can upgrade the functionality of our green machines over the cloud because of its reconfigurability. Also, the smaller size and the low power consumption led to a compact and efficient solution. We have used tools from analog devices in our design. The EVAL CN0398 board is used to read the measurements of soil moisture and soil pH accurately. Also, we use the power, charge and energy metering board LTC2946 to measure the power draw. This helped us give an insight into the power consumption and motivated us to make our green machines energy efficient. We have used the RFS daughter card from the Cloud Connectivity Kit to harness the network capabilities of the DE10 Nano. It facilitates the Bluetooth communication with the green machine units. The RFS also has Wi-Fi capabilities. We use that to connect to the cloud. Also, in case we have to expand our range, we can switch from Bluetooth to Wi-Fi to connect to green machine units because Wi-Fi provides connectivity in a longer range. The DE10 Nano in our green machine systems are connected to the Microsoft Azure cloud by provisioning the DE10 Nano as an Azure IoT edge device. The data is stored in a Cosmos database system in the Azure and can be analyzed to find out trends over time and improve the CNN and optimize the green machines. We also plan to use the collected data to predict the yield ahead of time. Additionally, we expect to create local agricultural communities over the cloud where the users can share the food grown in their homes. As you can see, our concept of green machine is a unique and an effective approach towards sustainable agriculture. These can be adaptable by a wide range of users like domestic users, farmers, and researchers due to the qualities the system possesses. We strongly believe that our system will immensely support to uplift the quality of life and the economic growth of the whole world. Thank you.